Hey guys, I'm Virat Singh of class 7. In this video, I'll solve the further part of chapter 3, which is Structure of Matter of Ratna Sagar class 7 science textbook. So let us start with the further part of this chapter, which is symbols. We know that there are 118 elements and millions of compounds. The element and compound react with each other in innumerable ways. Writing the full names of elements and compounds and describing their reaction is very inconvenient. It is more convenient to use abbreviation or symbols. So it is saying there are many elements, 118 elements and millions of compounds, and it is very inconvenient to write their full name and telling the reaction with the full names. So to make it convenient, we use abbreviation or symbols to represent the elements or compounds. We use symbol to represent elements. A compound is represented by a formula which contains symbols of elements present in a molecule of that compound. So a symbol is used to represent an element and a compound is represented by a formula which contains symbols of element present in it. So like if we take example of water is H2O. So it is telling the number of element and the name of element in the molecule of water, which are hydrogen and oxygen. Early scientists and alchemists used picture symbol to represent elements. Later, Dalton improved over these symbols. He used symbol this for hydrogen and this for oxygen. But as a number of known elements and compound increased, this method became very tedious. So in the early scientists used picture symbols to represent elements, but Dalton is a scientist in 90s. He improved these symbols, but as we discovered more and more elements and compounds, this way also became very tedious. The present system used letters of English alphabet to represent the elements. It was first suggested by Berzelius. The system is as follows. Some elements are represented by using the first letter in capital of name of the element. For example, C is for carbon, N for nitrogen and O for oxygen. So after Dalton introduced some symbols, when more and more elements and compounds were discussed, this method also failed. So the Berzelius, he was the first to suggest that we should use letters and numbers to represent the compounds and elements. So the system are as follows, in which some elements are represented by simply writing the first letter of that element. For example, C for carbon, N for nitrogen and O for oxygen. But it is to be noted that the first letter should always be in capital letter. Let's read further. Name of some elements have been the same initial letter. For example, carbon, calcium and cobalt. In such cases, the first letter is taken in capital together in small from its name. For example, Ca for carbon, Co for cobalt, Ba for barium and Br for bromine. So there are many elements and compounds, and there are many elements and compounds who start from the same letter, like for example carbon, calcium and cobalt. So we cannot use capital C in every element to represent. So if you have written a formula and you have written C, so it will be only carbon only, not if you have written C, it will not be calcium or cobalt, because if we take only one letter C for all, we will be confused that which one has to be written. So in this case, the second letter of the word of the element is written. For example, C is written for calcium, in which the first letter, which is C, is written to be capital, and A, which is the second letter, is to be written in the small. Example, Ca for calcium, Co for cobalt, Ba for barium and Br for bromine. The symbols of some elements are derived from their Latin names. For example, the Latin name of copper is cuprum and its symbol is Cu. The Latin name of potassium is calcium and its symbol is K. So, in some cases, the Latin name, the first letter of the Latin name is used as a symbol. For example, it is written as copper. Latin name of copper is cuprum. So it is written as Cu. And the Latin name of potassium is calcium. So its symbol is K. Now let me give another example. Let's take an example of tungsten. The example of tungsten is wolfram. So the symbol of tungsten is not T but W because the Latin name of tungsten is wolfram. Let's read further, which is formula. We know that molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen. The formula of water should be therefore contain symbols of hydrogen and oxygen. It should contain the number of atoms of each element in a molecule. We write the formula of water as H2O1 or simply H2O. So they are telling how to write the formula. So they are taking an example of water. So in water there are 2 atoms of hydrogen and 1 atom of oxygen. So we cannot write simply HO. It is not defined. So we shall write the number of atom in the molecule also with the symbol of the element, like H2O, which indicates hydrogen atoms are 2 and oxygen atom is 1. So if it is nothing written like H2O, in O it is written nothing, which means 1 atom. So if we describe, which is H2O1, or we can simply write it as H2O. Common salt is made up of sodium and chlorine. One molecule of common salt contains 1 atom of sodium and 1 atom of chlorine. So formula of common salt is Na1Cl1 or simply NaCl. So in common salt there is 1 atom of sodium and 1 atom of chlorine. So it would be written as Na1Cl1, or we can simply write it as NaCl. One molecule of ammonia contains 1 atom of nitrogen and 3 atoms of hydrogen. Its formula is NH3. So they are giving us more and more example, like in ammonia, it contains 1 atom of nitrogen and 3 atoms of hydrogen, which is written as NH3. Atom of element cannot exist independently in the nature. They form molecules containing 2 or more atoms. Thus, H2 represents a molecule of hydrogen, O2 a molecule of oxygen, Cl2 a molecule of chlorine, and N2 a molecule of nitrogen. So, it is saying that atoms of element cannot exist independently in the nature. The form of molecule will contain 2 or more atoms, means it cannot exist independently. And they are giving us example H2 of hydrogen, O2 of oxygen, C2 of chlorine, and N2 of nitrogen. Let's read further. These are tables, you can read and learn it. I'll read the main part only. In some compounds, 2 or more elements act together as simpler group. For example, in sodium sulfate, Na2SO4, SO4 represents the sulfate group, and in sodium nitrate, NaNO3, NO3 represents the nitrate group. So it is saying in compound 2 or more elements act together as a single group, like Na act as NO3 act as a nitrate group, NO3 act as a nitrate group, and Na act as sodium sulfate group. let's start with the atomicity. The atoms of some element can exist independent. Example are helium or He, neon or Ne. They are known as monoatomic elements. Their chemical formula is therefore the same as their chemical symbols. So, there are some atoms that can exist independently, like helium and neon, and they are known as monoatomic elements, and their chemical formula is same as chemical symbols. However, atoms of many elements cannot exist independently in nature. They form molecules containing two or more atoms. For example, molecule of hydrogen, nitrogen, oxygen and chlorine have two atoms each. They are known as diatomic elements. Thus, H2 represents molecule of hydrogen, N2 a molecule of nitrogen, O2 a molecule of oxygen and Cl a molecule of chlorine. So, some atoms can exist independently. They are known as monoatomic, and the ones which cannot exist independently, they are known as diatomic because they cannot live independently. Example are hydrogen, nitrogen, oxygen and chlorine. The number of atoms presented in a molecule of an element is known as atomicity. So the main definition of atomicity is the number of atoms present in a molecule of an element is known as atomicity. The atomicity of some common elements are given in table 3.6. So you can read the table 3.6 which is here. So in this video I'll explain till here only. In the next video I'll solve the further part of this chapter. So thank you guys for watching this video. If you have any queries related to this chapter, please drop it in the comment section below. I'll surely try to solve it in the next video. Till then, goodbye.